Hi everyone and welcome again to the session of Crash Course. Well, we are through with the first 4 questions. Let's move on to the next one. The 5th question talks about A, B, C, okay, 3 quantities such that A plus B plus C is 0. Modulus of A is equals to modulus of B is equal to modulus of C is equal to 1. Over here A, B, C are complex numbers, as you can see. Modulus of A minus B whole cube plus modulus of B minus B whole cube plus modulus of C minus A whole cube minus thrice of mod A minus B, mod B minus C, mod C minus A is a quantity which is an integral quantity which is equal to what is the question asking. So there is an integer which comes out as the answer of this query. What is that integer out of the infinitely many is what we have to find out. Over here, if you carefully observe, 2 facts are given to us. A plus B plus C is 0 and mod A is equals to mod B is equals to mod C is equals to 1. Right now, I am able to recall something which is mod of B minus C whole square and mod of B plus C whole square. Okay. What is this? What is modulus of B minus C whole square? It was equal to mod B square plus mod C square minus 2 mod B mod C. And what is mod B plus C whole square? It is mod B square plus mod C square plus 2 mod B mod C. If I add both of them, what do I get? I actually get mod of B minus C whole square plus mod of B plus C whole square is actually equal to mod B square plus mod B square, which is twice of mod B square, mod C square plus mod C square, which is twice of mod C square, and this plus this is obviously equal to 0. So this is what you actually have. Now if you focus upon this obtained expression, what you will be able to infer from here is, first of all, I can write this as twice of mod B square plus mod C square, and here I have mod of B minus C whole square plus mod of B plus C whole square. Now please go back to what is given to you. You are given that A plus B plus C is 0, which gives me that B plus C is equal to minus A. If B plus C is equal to minus A, mod of B plus C is mod of minus A, and mod of B plus C whole square is mod of minus A whole square. So this is mod of minus A whole square. This is as it is. And what is mod B? Mod B is 1, so mod B square is also 1. Mod C is 1, so mod C square is also 1. So over here you get twice of 1 plus 1, which gives you 2 into 2, that is 4. So eventually you get mod of B minus C whole square plus mod of minus A whole square is equals to 4. But you know that modulus of a complex number and its negative are exactly the same. So modulus of negative of A is same as modulus of A. But after treating modulus of minus A is same as modulus of A, you get this step. This is 4. But modulus of A is also given to be 1, so its square is also 1. So instead of this quantity, I can directly write 1. And so I get mod of B minus C whole square. Mod of B minus C whole square is 4 minus 1, that is 3. You all know that modulus of a complex number is a non-negative quantity, because of which I get modulus of B minus C is positive square root of 3, that is root 3. This I have obtained by just playing with B and C. By just playing with B and C throughout, as you can see, then I have obtained this particular fact about mod B minus C. Exactly in a similar fashion, when I play with C and A, I get mod of C minus A is also root 3, and when I play with A and B exactly in the same fashion, I get mod of A minus B is also root 3. Having obtained all these 3 expressions, I am now going to talk about what I need to find. I want mod of A minus B whole cube. If mod of A minus B is root 3, its cube is 3 root 3. Okay. Then what is mod of B minus C whole cube? Mod of B minus C is root 3, so its cube is cube of root 3, which is 3 root 3. Then you have plus mod of c minus a whole cube. Now c minus a's mod is root 3, so its cube is again 3 root 3. After this you have minus of thrice of mod of a minus b, mod of b minus c, mod of c minus a. So minus thrice of mod of a minus b into mod of b minus c into mod of c minus a, that means root 3 into root 3 into root 3, that means 3 root 3. So 3 into 3 root 3. What do you get? It's very simple. This is 9 root 3 and this is 3 root 3 plus 3 root 3 plus 3 root 3 means thrice of 3 root 3, which is 9 root 3. So this is 9 root 3 minus this is 9 root 3. Eventually you get the integral answer as 0. So the integer which is equal to this entire expression, having given this and this fact about ABC, is equal to 0. Is it understood? This was your integer type of question and the integer associated to this question as the answer is 0. I hope you've got the concept very, very clear related to this question. Okay, let's move on to the next one. Over here A, B, C are given as real numbers, okay. A, B, C are real numbers. In the previous question A, B, C were being given as complex numbers, right? Okay. Now ABC are real numbers and ABC are in AP. Please get these facts very, very clear, whatever is given to you. ABC are in AP, well, I know a property related to 3 consecutive terms to be in AP, which is twice of the middle term is equals to sum of first and the third. This is given to me throughout any part I deal with. I am given this universal thing. Okay, corresponding to any part, this thing is given to me that twice of B is A plus C or ABC are in AP. Having this as the universal given condition, match the expression in column 1 with the correct condition or property in column 2. If A square, B square, C square are in AP, then which among these is going to follow? Now ABC is already in AP, along with it you are being given now that A square, B square, C square are in AP. So first thing is that this is already there. Then it says A square, B square, C square are in AP. So if A square, B square, C square are in AP in this order, then again twice of the middle term is sum of the first and the third. So you get this implies twice of B square is A square plus C square. At this point of time, please try to realize you have 2B is equals to A plus C and then you also have 2B square is equals to A square plus C square. Somehow you need to connect both of these given conditions in order to correctly reap the condition corresponding to A and then match it with that one. So over here I have A plus C, here I have A square plus C square. So obviously when I square A plus C, terms like A square and C square pop up. So what do? I consider A plus C whole square. A plus C whole square will be 2B whole square according to my given conditions. But actually A plus C whole square is A square plus C square plus 2AC. And 2B whole square is 4B square, which I can write as twice of 2B square. 4B square can be written as twice of 2B square. But 2B square is same as A square plus C square. So this 2 remains as it is. This 2B square is replaced by A square plus C square. Cool enough? And over here you already have A square plus C square plus 2AC. And on the right hand side you have 2A square plus 2C square. Now please understand, 2A square minus A square gives you A square. 2C square minus C square gives you C square. And minus 2AC is equal to 0 is what you get after resolving. So this gives you A minus C whole square is 0. If A and C are real quantities, A minus C is a real quantity and square of it is 0. You know that square of any real number is 0 if and only if that real number itself is 0. So if square of this real number is 0, this implies this real number itself is 0, which eventually means A is same as C. So if A, B, C are in AP and A square, B square, C square are in AP, then A is equals to C. But if A comes out to be equal to C, you eventually start getting twice of B is A plus A, which is 2A, which eventually means B is equal to A. But A is equal to C. So you get that the condition which correctly matches with A is that A is equals to B is equals to C. Whenever A, B, C are in AP and along with it A square, B square, C square are also in AP, that is only possible when A is equals to B is equals to C, and that is how you obtain this. So corresponding to A, the correct match is A is equals to B is equals to C, which is P. So your A gets matched to P. Your A gets matched to P. Let's talk about the next one. In the next very option, it says that A, B, C are in AP already, which is a universal given condition to me. Along with it A square, B square, C square are in GP now. Okay. So now A, B, C are already in AP and I am being given that A square, B square, C square are in GP. Let's try to deal with this. Now what do you mean by 3 consecutive terms being in GP? 3 consecutive terms being in AP meant that twice of the middle term is sum of the first and the third. But 3 consecutive terms being in GP means square of the middle term is the product of the first and the third. So if in this case you are given that A square, B square, C square are in GP, then square of the middle term is product of first and the third. Okay, carefully analyze the situation. This means B to the power 4 is A square C square, or B square whole square is A square C square. So B square is nothing but plus minus square root of A square C square, which means plus minus square root of AC whole square, right? Which means this is equal to plus minus AC. What is equal to? B square equal to plus minus AC. But this is always non-negative. So what eventually you infer from here is that B square is equal to AC. The fact that B square is equal to AC when you are already given that 2B is A plus C and A square, B square, C square are in GP. With these two as given conditions, you are obtaining that B square is same as AC, which means what? What do you mean by B square is same as AC? This means A, B, C are in GP, isn't it? When square of the middle term is product of first and the third, you say that this is a sequence which is a GP, that is geometric progression. So whenever ABC are in AP but A square, B square, C square are in GP, then ABC are in GP. So eventually what are you getting? You are getting that ABC are in AP and ABC are in GP. If 3 terms in the same order are in AP as well as in GP, what do you mean? See, you are getting A, B, C are in AP and they are in GP. This means what? This means 2B is also equal to A plus C, and in fact B square is also equal to AC. When you solve both of this, you actually get A is equal to B is equal to C. Because if 3 terms are in AP as well as GP, that eventually means that they are equal to each other. It's just like the AM-GM inequality. If you remember, I told you in general AM is greater than equal to the GM. But if AM turns out to be equal to GM, then the quantities have to be equal. That can only happen, the equality can hold between AM and GM of finite number of non-negative terms only when each of those terms is equal to one another. Similarly, ABC are in AP and GP, that is happening. That means A is equals to B is equals to C. So even B is getting matched to P in that situation, right? So B gets matched also to P. Right? Let's talk about the C case. Now over here, when I have case C with me, It says that A square, B square, C square are in HP when you already have that A, B, C are in AP. Okay, so A square, B square, C square are in HP. A square, B square, C square are in harmonic progression. 3 terms are in harmonic progression only when the middle term is equal to twice of product of first and the third upon sum of first and the third. So if A square, B square, C square are in HP, that means B square is twice of A square, C square upon A square plus C square. Okay. Now that you have obtained this, please try to understand, if I write B in terms of A and C, my entire expression will be in terms of A and C. So it's always a good technique to reduce the number of variables or unknowns involved. B, because 2B is A plus C, B can successfully be written as A plus C by 2. So you have A plus C by 2 whole square is 2A square C square upon A square plus C square. When you resolve this very easily, you get A plus C whole square plus 2AC into A minus C whole square is 0. This entire expression, you resolve it to this expression. Basically, you bring everything to the left hand side and equate this expression to 0. Now, if product of two things is 0, that is only possible when either this is 0 or this is 0. So, this is holding, this and this is holding when either this is 0 or this is 0. Now, A minus C whole square is 0 means that A minus C is 0 means that A is equal to C. But if A is equal to C and twice of B is already given to be equal to A plus C and A is equal to C, that means B also is equal to A is equal to C. So, if A is equal to C and twice of B is A plus C, that means B is also equal to A is equal to C. Or either this is 0 or this is 0, that means A plus C whole square plus 2AC is 0. But A plus C is same as 2B. So, that is 2B whole square is equals to minus 2AC. I can write it like this by shifting 2AC to the right hand side. This becomes 4B square is minus 2AC, which means 2B square is minus AC, which means B square is minus AC by 2. Now, I can write minus AC by 2 in two ways. Either I can write it as minus 1 by 2 times A into C, or I can write it as A into minus 1 by 2 into C. If B square is coming out to be the product of these two terms, this means minus 1 by 2 A, B and C are in GP, because you can see square of the middle term is product of first and the third. And if B square is coming out to be equal to A into minus C by 2, this means A, B minus C by 2, they are in GP. So, for ABC to be in AP and A square, B square, C square to be in HP, this or this should hold. That means this should hold, or this should hold, which means A is equal to B is equals to C, minus half A, B, C are in GP, A, B minus half C are in GP. All P, Q, R are correct options to be matched to case C. So, C gets matched to P, Q, R. P, Q, R. Is it understood? Moving to the last case, that is case D. It says that A, B, C are in AP and A plus B plus C is 3 by 2. Now, this is very, very easy. If you have A plus B plus C is 3 by 2, okay, but because A, B, C are in AP, twice of B is A plus C, so I can replace A plus C by twice of B, plus B is 3 by 2. So, you get 3B is 3 by 2 or B is 1 by 2. Okay, so your D gets matched to S option. D gets matched to S. And this is how you accomplish the solution of this question. I hope it is crystal clear. Let's move on and talk about the solution of the next question. Suppose 4 distinct positive numbers A1, A2, A3, A4 are in GP. So now you are given that these are 4 distinct positive numbers which are in GP. For sequence to be a GP, we just need non-zero terms. It's specifically given to us that they are positive terms as well. So if you have A1, A2, A3, A4, they are in geometric progression. That means there is a common ratio getting involved, which is what? Second term upon first term, third term upon second term, fourth term upon third term. All these ratios are equal and they are equal to some common ratio which we denote by R. So suppose this is GP with common ratio equal to R. That means you get A2 upon A1 is R, A3 upon A2 is R, A4 upon A3 is R, which eventually gives us a very easy way of expressing them just in terms of first term and common ratio. So first term, if I am taking as small a, A2 becomes what? If this is small a, A2 becomes AR, A3 becomes what? R A2, but A2 is AR, so R into AR, which is AR square. What is A4? A4 is A3 into R, but A3 is AR square into R is AR cube, so A4 is AR cube, right? Now, A1, A2, A3, A4 are in GP has landed us to such a representation of these 4 in terms of the first term and the common ratio. Further, the question says B1 is A1, so we are defining B1, B2, B3, B4 as 4 new quantities. B1 is what? Let me rub this. Okay, so B1 is equal to A1, A1 was my equal to A, B2 is B1 plus A2, so B1 plus A2, B1 plus A2, B3 is B2 plus A3, B2 plus A3, A3 is this, and what is B4? B4 is B3 plus A4, so B3 is A plus AR squared, this is B3 plus A4, so A4 is AR cube. Have you got this? With the help of the given 4 quantities in GP, I am defining 4 new quantities B1, B2, B3, B4 in this order. This is A times 1 plus R, A times 1 plus R square, A times 1 plus R square plus R cube. Question further says that the numbers B1, B2, B3, B4 are neither in AP nor in GP is statement 1 and the numbers are in HP is statement 2. So basically we need to check whether these 4 numbers are in AP, GP, HP or not. What is the case happening with them? If I need to talk about them being in arithmetic progression, I need to check whether B2 minus B1 is equal to B3 minus B2 is equals to B4 minus B3 or not. So if I consider B2 minus B1, you can clearly see B2 is A plus AR minus A, which is AR. A plus AR minus A, which is AR. Then if I talk about B3 minus B2, B3 is A plus AR square minus A minus AR. So plus A minus A plus AR minus AR, answer is AR square. Right here itself I stop because I see that B2 minus B1 is not equal to B3 minus B2. B2 minus B1 is not equal to B3 minus B2 and therefore B1, B2, B3, B4 are not in AP. Definitely they are not in AP. What about them being in GP? If I talk about them being in GP, I need to talk about what? B2 upon B1 should be equal to B3 upon B2 should be equal to B4 upon B3. So if I talk about B2 upon B1, it is actually equal to A plus AR upon A, which gives you 1 plus R. Because A comes out common, you are left with 1 plus R. So A cancels out, you're left with 1 plus R. Similarly, if I talk about B3 upon B2 next ratio, let's see if it also comes out to be 1 plus R. Then we will check the last ratio B4 upon B3. If that also comes out to be equal to 1 plus R, then we will declare that this B1, B2, B3, B4 sequence is in GP. Even if one ratio does not come out to be equal to 1 plus R, then I will say the sequence is not in GP. So let's check B3 upon B2. B3 is A times 1 plus R square, and B2 is what? A times 1 plus R. Clearly you can see this is coming out to be 1 plus R square whole upon 1 plus R, which is not equal to 1 plus R. So you have no need to further check the ratio B4 upon B3, because already you are getting two unequal ratios, and therefore you will say that B1, B2, B3, B4 are not in GP. So your statement 1 is actually correct, that these terms in this order are neither in AP nor in GP. This is true. Now it talks about the numbers being in HP. So rather than checking the numbers being in HP, that is harmonic progression, we will check whether their reciprocals correspondingly are in AP or not. So if I need to check that B1, B2, B3, B4 in this order are in HP or not, I need to realize the fact that B1, B2, B3, B4 are in harmonic progression if and only if 1 by B1, 1 by B2, 1 by B3, 1 by B4 are in arithmetic progression. If these four terms fail to be in AP, then these four terms fail to be in HP. So because AP concept is much more familiar and convenient and easier than the HP concept, of course I am going to be using this approach and not dealing with B1, B2, B3, B4, rather than dealing with 1 by B1, 1 by B2, 1 by B3, 1 by B4. So let's check whether these four terms are in AP or not. If I talk about 1 by B2 minus 1 by B1 and I talk about 1 by B3 minus 1 by B2, realize that if this is B1, 1 by B1 is 1 by A. This is B2, 1 by B1 is reciprocal of it. This is B3, then 1 by B3 is reciprocal of it, and this is B4, 1 by B4 is reciprocal of it. So reciprocal of B2 minus reciprocal of B1, you will find will not come out to be equal to reciprocal of B3 minus reciprocal of B2, or reciprocal of B4 minus reciprocal of B3, in which case I will get these two subtractions to be unequal, which would mean that 1 by B1, 1 by B2, 1 by B3 and 1 by B4 are not in AP. If these are not in AP, their reciprocals are not in HP, and therefore B1, B2, B3, B4 is not in HP. It says that they are in HP whereas they are not in HP, so statement 2 is false. It says that statement 1 is true and statement 2 is false, so B is the correct option. Is it clear? So I hope the questions discussed in today's session were correctly understood. Please revise the 7 questions we've done till now. They all involve very nice concepts and they're going to help you brush up through the entire chapter from where they have been picked up. We're going to move ahead and study more questions in the next lecture. So I'll see you then. Thank you.